Hello, in this video, we're going to take a look at the integral of 1 over 1 minus sine x dx. To accomplish this integral, we need some basic trig identities, but knowing how we can manipulate this 1 over 1 minus sine x to get to these trig identities. So the big trig identity that comes up here is that sine squared x plus cosine squared x equals 1. With a little bit of rewrite, this also means that 1 minus sine squared x is cosine squared x. We have something that looks a little bit like 1 minus sine squared x. We have 1 minus sine x. And we can make 1 minus sine x look like 1 minus sine squared x by multiplying by 1 plus sine x. Because if I factor this is a difference of squares. 1 minus sine squared x is the same as 1 minus sine x times 1 plus sine x. Well, I'm going to multiply that denominator by 1 plus sine x. However, as I multiply the denominator by 1 plus sine x, I need to keep my integral the same, so I need to multiply the numerator by 1 plus sine x as well. This integral is the same as the integral of 1 over 1 minus sine x. But as we've identified over here on the side, 1 minus sine x times 1 plus sine x is cosine squared x. Our new integral is 1 times 1 plus sine x in the numerator, and in the denominator, we have 1 minus sine x times 1 plus sine x, which is 1 minus sine squared x, or cosine squared x. And now, because our addition is now in the numerator, we can split this up into two different fractions. We have 1 over cosine squared x, and we have sine x over cosine squared x. This is 1 over cosine squared x is the same as secant squared x, and we know the integral of secant squared x, that is tangent, and sine over cosine squared is the same as sine over cosine times 1 over cosine. And identifying that sine over cosine is tangent, and 1 over cosine is secant, we now have another thing. We know the antiderivative. We know the antiderivative of tangent secant is secant. So this becomes tangent. This will become secant, making our antiderivative tangent x plus secant x plus c. Now, if we didn't identify here that sine x cosine squared x was tangent times secant, we could have also integrated that with a u sub. I'm going to demonstrate that u sub, or how we could find that antiderivative if we didn't recognize it. And this would be using the u sub of u equals cosine x dx. Cosine x du equals negative sine x dx, or negative du equals sine x dx. So our numerator is going to become that negative du, and our denominator will become u squared. So this is equal to the negative integral of 1/u squared. Cosine squared becomes u squared. And 1/u squared is also u to the -2. Using the power rule on this, we add 1 to our exponent. And then divide. So dividing by -1 is the same as multiplying by -1. So we get a u to the negative first plus c. U is cosine. We have 1/cosine x plus c. And as stated, 1/cosine is secant. So if we hadn't identified that sine over cosine squared was tangent secant, we can still get to the same exact antiderivative by using a u sub. But whichever way we go about it, the antiderivative or the integral of 1/1 minus sine x is tangent x plus secant x plus c.